Hello and welcome to lecture series on Introduction to Electrodynamics. We have three different types of first order derivative, vector derivative, gradient, divergence and curl. And we can make five species of second derivative from those. So the first is divergence of gradient. And the second is curl of gradient, 2 from the gradient, and gradient of gradient is have no meanings. Then third is gradient of divergence. So we have a gradient of del dot v. The fourth one is divergence of curl. And the fifth one is curl of curl. Curl of curl. So we have to work out the possibilities of these second derivatives. So if we look at the first, so we have divergence of gradient. So divergence of gradient, we have x partial over partial x, y partial over partial y, z partial over partial z, plus the del, then dotted with partial t over partial x plus partial t y plus partial t partial z. So this is gradient of t, and when we check the dot product, it turned out to be partial square or partial x squared t plus partial y squared plus partial t or partial z squared. So we can write this as a delta square of t, where delta square is or del square is partial over partial x square plus partial over partial y square plus partial over partial z square, and it's called the Laplacian operator. So from divergence of gradient, we obtain second derivative in terms of partial over partial x square, partial over partial y square, and partial over partial z square, which is given a name called the Laplacian operator. Let's check the other possibilities. Let's check 2. So 2 is the curl of a gradient. So this is an identity del cross del t is equal to 0. And this is important fact because del t is, or the gradient of any scalar function, will be providing us a minima or maxima or a point of pause. So for a point of pause or minima maxima, or there will be no curl. So it's always true to the curl of gradient is always 0. Let's check the third one. Del into del V, and it is yeah, again it's a valid operator, like del dot V is scalar function. Scalar, the gradient of a scalar have it will be there, but usually does not appear in application. And then we have fourth one, which is del dot del V, and again it turned out to be 0. The curl, the divergence of a curl is always 0. So again, for any vector which have curl, it will not have any divergence. That's in our previous example when we were solving the curl. We saw that the field which have a curl which is usually don't have the divergence, and it's always true. So the fifth one is del cross V, and it can be written as del dot del V minus del square V. So this was first, right? And this was third. So the fifth one turned out to be not anything else, but is the combination of first and third. So for the product rule, for the second derivative, we only have two important quantities. So that is the gradient of a divergence, which is here, and the Laplacian. And again, this third one usually not appear in application. The most important one for the second derivative we will be looking will be the Laplacian operator in our formulation. For the second derivative, we will be dealing with the Laplacian operator most likely. So we will continue with next section, which is integral calculus, and see you in the next lecture.